This is the second set of practice problems that were gone through in the video in the lesson. We're multiplying and simplifying radical expressions, and I put up the answers kind of quickly, and I did not go through any detail on how we got those answers. So I'm going to spend some time now and go through how we got those answers. So if you were lost or if I went too quick, you can follow along. So I'm going to use the document camera, and we're going to work through these two problems. So for the first one, again, to simplify the radical, we need to find a common factor that can divide away to 1. So in the numerator, 1 minus y, we're kind of stuck with that. There's nothing to factor out of 1 and y. But for the denominator, this happens to be a difference of perfect squares. This comes up a lot. So we've got y squared is y times y. 1 is 1 times 1, and it is a subtraction. So this, I'm going to move down here. The numerator, I would keep the same. Y squared minus 1, I can factor that to y minus 1 and y plus 1. So those are conjugates, and when you FOIL that out, you're going to get the original expression y squared minus 1. Now I look for a common factor. I'm close here. I've got 1 minus y and y minus 1. That is very, very close to being what I want it to be, but it doesn't quite work out. So if I want to get this to work, I need to change this y minus 1 into a 1 minus y, really is what I want it to be. Or I could change the numerator to y minus 1. In fact, I'm going to do that. So what I can do to do that is use that handy trick that was going over in the lesson. Is I'm basically going to factor out of this numerator a negative 1. Now, I said we didn't need to do anything with the numerator. We could leave it alone. That's true. 1 minus y is factored. But if I want to rearrange it, I can. So I'm going to factor out a negative 1. And that's going to give me this result. And remember that if you distribute through, negative 1 times y is negative y. And negative 1 times negative 1 is a positive 1. So it does give you the same result. And now, y minus 1 and y minus 1 are common factors. They divide to 0. My final solution then would be negative 1 over y plus 1. Or the negative could be in the numerator. It could be negative 1 over y plus 1. It could be in the denominator. And so I'm going to kind of put that on the side here, that the negative, it doesn't matter where you choose to put it. It could be in the numerator, it could be in the middle, or if you were trying to be really fancy, you could do that, I suppose. But really, all these give you the same result. And so that any of those are correct. For the second one, the numerator, again, this y minus 1, I'm going to leave it for now, unless I need to change it, but for now I'll leave it alone. The denominator here in this first fraction, I can definitely factor that, y minus 1. I'm trying to find, there's no coefficient here before y, or before the initial coefficient. And so I can find two numbers that multiply to negative 6 that also add to negative 1. Remember, even though there's not a 1 right here, you could always imagine there being a times 1. So I'm going to go with, I think, negative 3 times 2 is negative 6, and negative 3 plus 2 would be negative 1. So I can factor this to y minus 3 and y plus 2. That doesn't help me too much yet. The numerator here, the second fraction, I can factor that, kind of like I did for the first one. These are both positive, so I'm going to go with positive 3 and positive 2. Y plus 3, y plus 2. And again, you can FOIL that out and see that 3 times 2 is 6, 3 plus 2 is 5, and it works. Again, just like before, we had y squared minus 1. We use a difference of perfect squares. Y squared minus 1 shows up again here. Now I'm looking for common factors. I factored everything. I want to find common factors that can divide to 0, or to 1, excuse me. I've got a y plus 2 and a y plus 2. Those divide to 1. Y minus 1, y minus 1, that divides to 1, which means in the numerator, I'm left with y plus 3. And in the denominator, I've got y minus 3 and y plus 1 left over. And that's about as far as we can take that one. So that would be our final answer for this one as well. And that's how we got those results.